In this video, we will understand meaning of fatigue, SN curves, detail categories, and permissible stress to be taken in fatigue design. Fatigue in steel refers to the phenomenon where a material experiences failure under repeated or fluctuating stresses that are well below its ultimate tensile strength. This process occurs due to the progressive accumulation of damage within the material, typically initiated at microscopic defects, such as cracks, inclusions, or surface irregularities. Over time, these imperfections grow larger with each stress cycle, eventually leading to fracture. Fatigue failure is not instantaneous. It develops in stages. Initially, tiny cracks form at high-stress concentration points, such as sharp corners, welded joints, or surface scratches. In railway girders, it typically starts from rivet holes or bolt holes. These cracks then propagate incrementally with each cycle of stress. The final stage occurs when the remaining uncracked cross-section of the steel is unable to sustain the applied load, causing a sudden and catastrophic failure. This photo taken from internet shows one such example. With this discussion now, we can appreciate how important it is for bridge engineers to understand fatigue phenomenon. With this background, we can start reading IRS Steel Bridge Code. As per Appendix G of IRS Steel Bridge Code, fatigue in materials is the phenomenon which causes failure of any structural members under the action of repetitive loads. Failure of structural member in fatigue takes place at stress levels that are substantially less than those associated with failure under static loading condition. For definition purpose, fatigue is the process of progressive, localized, permanent structural change occurring in material subjected to conditions which produced fluctuating stresses and strain at some point or points, and which may culminate in cracks and complete fracture after a sufficient number of fluctuation. Railway bridges are dynamically loaded structures which are subjected to complex fluctuating loads of varying amplitudes. There, an assessment for fatigue is required to be made if the bridges are to be designed for a definite service life. To understand fatigue from design point of view, first some basic fundamentals need to be understood. Let's start with SN curve. An SN curve, also known as a stress number curve, represents the relationship between the cyclic stress amp and the number of cycles it can endure before failure. The graph plots stress on the vertical axis and the number of cycles to failure on the horizontal axis. To account for the vast range of cycles, from a few to billions, the horizontal axis is typically displayed on a logarithmic scale. The curve usually begins at high stress levels for low cycle fatigue, where the material fails quickly under large stresses. As the stress amplitude decreases, the number of cycles increases, extending the material's lifespan. For steel, the curve may plateau at a specific stress level, indicating a cut-off limit. Below this stress, the material can theoretically withstand infinite cycles without failing. In SN curves given in IRS Steel Bridge Code, you will find that there are many SN curves drawn for different detail categories. It's important to understand what is a detail category. To understand detail categories, we will have to go to Table G2 given at the end of Annexure G. Detail category refers to a number which represents stress range in Newton per millimeter square, which if applied for 2 million cycles can be sustained by a particular construction detail. Construction detail means the arrangement of steel plates or sections in fabricating a steel bridge member, like cross girder, bottom chord, etc. In essence, how a member has to be fabricated. It may be a built-up section or a rolled section. It may be connected with other members with the help of welds or bolt and holes, etc. Each such arrangement is basically a detail category. All possible types of detail categories are tabulated in Annexure G itself under various tables named G-2. For example, Table G-21, which is for non-welded details, mentions a detailed category of 160 for constructional detail 1 and 2. It means that a steel structural member made as per constructional detail 1 or 2 can successfully sustain 2 million cycles of stress range of 160 Newton per millimeter square. Please note that SN curve is only dependent upon detail category and not on steel grade. Here, detail categories are 36, 40, etc. Up to 160, that means maximum detail category, which a construction detail have, is 160 Newton per millimeter square. Basically, this 160 detail category is for rolled steel sections, which are made in factory and are supposed to have least flaws and irregularities. As we keep on introducing welds, as in built-up section and holes for connection, etc., the detail categories keeps on reducing. For various construction details, the detail category to be taken may be referred by Table G-2. Now let's take an example of cross girder or stringer of our typical RDSO standard open web girder. It's a built-up I-section with holes at ends. How to select appropriate detail category in this case for the purpose of fatigue design. It is to mention that in Table G2, there are 3 construction details given, which show the I-section with bolted connections matching our requirement of cross girder or stringer. So overall, we have 3 options to choose from: construction detail 6, 7, or 8. Construction details 6 and 7 have a detail category of 90, and construction detail 8 has a detail category of 80. In fatigue considerations, whenever exact detail category is not met, the lower one should be adopted. This is legislated in the EN 1993-1-9 code, which is EN code for fatigue design. So we will choose a detail category of 80. It means that a cross girder or stringer made as per the chosen construction detail as above can survive for 2 million cycles of a stress range of 80 Newton per millimeter square. It also means that for the purpose of fatigue design, the permissible stress in fatigue shall be taken as 80 Newton per millimeter square. In IRS Steel Bridge Code, 5 such tables are given. Table G-2-1 is for non-welded details. Table G-2-2 is for welded built-up sections. Table G-2-3 for transverse butt welds. Table G-2-4 is for welded attachments and stiffeners, and Table G-2-5 is for load-carrying welded joint. It's important to mention here that these tables are exactly taken from EN 1993-1-9 code for fatigue and were developed after thousands of fatigue tests and real-life design examples. The detail categories may appear very conservative, like taking a value of 80 Newton per millimeter square in a steel of grade 250 appears to be highly conservative. But as the bridge has to survive for 100 years, therefore we should not immediately jump to such conclusions. Fatigue is a silent phenomenon which remains invisible for a sufficient service life of a bridge. Please note that the detail categories are also basically permissible fatigue stress values used for design, and these are not dependent upon grade of steel. SN curve of structural steel is same for E250 or E350 or any other grade of structural steel. It is only dependent upon the construction detail, that is, arrangement of steel plates adopted to form a bridge component. That's why latest correction slip ACS-24 of IRS Steel Bridge Code prohibits use of steel of grade higher than E250 for designing members which are governed by fatigue. Tension members, flexors members, and members where reversal of stresses take place are the members, design of which is governed by fatigue. Using a higher grade of steel where section is being decided based upon detail category, which is independent of steel grade, will not result in achieving any reduction in section. You can watch a separate video to understand ACS-24, link of which is given in description. For the purpose of understanding fatigue design or calculating residual fatigue life, it is very critical to understand these two concepts of SN curves and detail category. We will understand fatigue design in depth in further videos made on the subject. That was all on the current topic. Tell us your topic in comments on which you want to watch a video. Subscribe for more such content.